I'm a futurist. I always feel like when I say that, it's like, hi, I'm Steve, I'm an alcoholic. No, I'm a futurist. What does that mean? I want to talk today about how technology is going to provide opportunity for people like you to make a difference in the world. You're all here because somehow you feel you want to make a mark on the planet. You want to help people with some kind of development, some kind of innovation that you are passionate about. One of the tools that you will have at your disposal to help you to do something amazing for the world is going to be computing. So I work for Intel. As a futurist, I look at the world through the lens of computing, and I think we are entering what I call Moore's era. And I'll explain what I mean by that. And it provides all kinds of opportunity for you. We're going to see more impact, more capability, more change driven by computing in the next 10 years than the last 50. And that's exciting. Let's start with a futurist. What? It's kind of a bullshit title. That's okay. I think about people. What do people want? What do they love? What do they hate? What are they scared of? What are the challenges that they have in life? What are their aspirations? And then I also think about technology. How is technology going to evolve? How is technology going to come to a price point where it can have a big impact? And finally, I think about the business ecosystem, the regulatory environment that technology is going to go into before it can help solve people's problems. That's my job as a futurist, is not to predict the future. A good futurist, I don't think, predicts the future. A good futurist helps people understand what will be possible and makes people think about the questions, what do we want to build and what do we want to avoid? And those are two very important questions whenever you think about the future. So we are in the era of Moore. Gordon Moore was one of the co-founders of Intel. He coined Moore's Law. Moore's Law, by the way, says that every couple of years, you'll be able to have twice the number of transistors on a chip. And transistors are to silicon chips like cells are to our bodies. The more you have of them, the more complex the structures you can create. The smaller those transistors become, the cheaper they become. Moore's Law is 50 years old this year. And Moore's Law has given us all kinds of impacts on the world. And it's going to continue to do that for at least the next 10 years. Gordon Moore, this is a picture of him looking fabulous and young and groovy in the 60s. He said, whatever can be done can be outdone. Moore's Law is not a law. Moore's Law is about belief. It is about belief for engineers that they can do something this year that they didn't think they could do last year. What Moore's Law gives you is the ability to take the design that you had last year for your chip, and next year you can put twice the amount of capability into the same area. More graphics, more USB ports, whatever that might be. More DNA analysis could be. Or you can shrink that. You can shrink that same design you had last year and next year make it for half the price. Because what you're able to do is to make things either much bigger and more capable or smaller and smaller and smaller. You add that up over time. Over a number of generations, you either get very, very tiny chips, and that's why you're starting to see discussion of the Internet of Things and wearables and ingestibles and implantables. And on the very other end of the scale, you get these enormous, powerful computers that are going to solve many of our problems by allowing us to unlock the secrets of the universe, to give us the computing capability, to do research, to provide capability to many of the devices that we live with in our lives. We're living in an era of exponential economics because every couple of years you get 2x, 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 2x. The Google guys understood this. Do you remember when Gmail came out? It's got a gigabyte of storage. Everyone, oh my God, how are they going to make money on that? It's because they were thinking exponentially and not linearly. So you're living in Moore's era. Think exponentially. Think what you can do with the exponential capabilities that Moore's Law will bring you in the next decade. Because over 5 decades, we've gone from computers that filled an entire room and were really not able to do very much, to computers that are incredibly powerful and now usable by pretty much anybody. Devices are part of all our lives. As I look out in the audience here, I see people with their laptops and phones. Devices are something we take with us everywhere. They've become pervasive for billions of people on the planet. And those devices are all connected to something. 40% of the planet is now online. And as you heard from Google yesterday, there are plans to figure out how do we get a much higher percentage of the planet connected to each other, connected to services, connected to opportunities for innovation. But computing is obvious in certain parts of our lives. It's maybe not as obvious, but it has a huge impact on the way that we live. Think about the toothbrush that you hopefully used this morning before you came here. How did that toothbrush get made? It didn't get whittled by a little old lady living in the woods. It was made by a computer-controlled manufacturing system. It was designed on a computer. The position of those bristles is there to get all the crap off your teeth. That was designed specifically and modeled in a computer. So even the simplest devices in our lives are things that were designed as a benefit of Moore's law. It's an invisible law. The cars that are driving in the streets outside are made safer because they were crashed over and over again inside the mind of a computer. The parts inside it were all designed on a computer. So it's had a huge impact, but it's also had an economic impact. IHS released a study last week where they estimated that the economic impact of Moore's law is $12 trillion worth of value creation. 12 trillion sounds like a big number. That is the GDP of the UK, France, Germany, and Italy combined. So it's had a huge impact on the planet. And if it had just slowed down a little bit, Moore's law, every 2 years, boom, 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 innovation every 2 years. If it had just slowed down to every 3 years, the technology that we have now would be the technology that we had in 1998 when Armageddon was in the movie theaters. We'd all be using computers that looked like this. You remember those? So the pace of Moore's law matters. Keeping up with Moore's law matters. So the question is, what comes next, and how can you use it to change the world? That's what I want to spend the rest of my time talking about. Now, what's happening with Moore's law is it's helping us bridge the gap between the physical world and the digital world. And bridging that gap is going to continue. Because as compute gets smaller and smaller and smaller, it's enabling us to embed computing in all aspects of the world. And I'll talk more about that. IoT and wearables are great examples. It also enables us to sense the physical world and take the physical and make it digital. Traditional sensing, smart sensing, I'll talk about, and machine vision. The other side of Moore's law is things are not just going to get much smaller, they get much bigger, much more powerful computers that are able to learn. They're able to run a whole new class of algorithms that can learn from the world, from the data that they receive. And not just running analytics, but having artificial intelligence. And then finally, you can come back from the digital to the physical. We'll talk a little bit about augmented and virtual reality and autonomous machines. So Moore's law is going to help us bridge this gap and continue to have the physical and the digital combine and blur together. So the corollary of Moore's law is Bell's law. Bell's law says that every 10 years or so, the devices in our lives that are enabled by computing become an order of magnitude smaller. So I'll show you what that means by that. Computers used to fill a room. Then they became something that came into our homes. Then they folded up under our arms and went to Starbucks with us. And now they're in our pockets and purses. The next thing is they go onto our bodies. And the part after that is they go into our bodies. And they become part of the world around us. Computing is closing in. It's closing in on our brains. It is coming closer and closer to our brains. It's coming into our eyes. It's coming into our senses. So computing is getting closer to us. And at the same time, it's disappearing. The moment computing is something you're aware of, you see it, there's a shiny screen of some kind. That shiny screen is going to go away, and intelligence will just be part of the world around us. This is a tiny computer. That's a cent. That's a US coin cent. But most countries have a tiny coin. If you think about the smallest coin in whatever country you come from, it's about that size. And that thing on top of it, that's a computer. That is a computer that is a millimeter by a millimeter by a millimeter. The next step is these motes, these tiny computing elements, are going to get more capable, but they're also going to get smaller. We're heading towards ones that are less than 0.1 millimeters across. At that point, you can start to put them inside the body. You can start to plow them into fields and put intelligence throughout the world. What this leads us to is this idea that we can think about making everything smart. Here's a beautiful teddy bear. Think about the teddy bear that you grew up with. Think about that teddy bear. You loved it, right? He was your friend, your buddy. What if that teddy bear was smart? And I'm not talking about like the movie Ted that talks back to you and is foul-mouthed and does disgusting things. Think about the cute teddy bear that can read a book to a child. How many of you here are parents? Any parents in the room? A few. Okay, so you know, I'm not a parent, but I know people that are. They're all good people. And when your child wants you to read a book, Daddy, read it again. Have you heard that one? Parents? Read it again. Well, after the third or the fourth time of reading the book, you can sense that cold beer in the fridge downstairs. Wouldn't it be nice to be able to say, Teddy will read it for you the next time? So hand off to the teddy bear. So I'm not suggesting that you abdicate your parental responsibilities, but maybe the fourth or fifth time, it's okay. So now the teddy bear could read a book to a child. Because it's sensing, it's smart, why not? So imagine that teddy bear. How much is that teddy bear worth, by the way? $40? 50 euros? 70 pounds? I don't know. That's one way to think about it. But the business model behind that teddy bear can now change. Because not only does that teddy bear start to become a great product, maybe you can start to sell it as a service. Maybe it's a 20 euro teddy bear with a 5 euro a month reading service. And that's for reading in English, to read an English book in English, or a French book in French. What if you wanted, maybe you could sell a service for an extra 3 euros a month that can read a book that's written in French or English and translate it into Chinese so that your child can learn another language. How much is that worth? So as soon as you start to make objects smart, you can think about them in a different way. They shift from being products to being opportunities to sell services. They allow you to create new value, and they allow you to customize the experience. 79% of people between 15 and 35 that were surveyed last year said they wanted to buy customized products. Most products are not customizable today. So this is a way to think about delivering customizable capabilities. Let me give you another example of what making objects smart can do. This is a headlight on a car. And you can see it really hasn't changed much in about 125 years of motoring. It's still a point source of light that shines forward with a mirror around it. That's the way headlights are. So the question I want you to challenge all of yourselves with, think about the objects in your life and ask this question. What if I made that object smart? What would happen with a headlight if I made it smart? Let me give you an example. What if I replaced my car headlight with a camera that looked out of the front of the car? And I could use a computer, because computers are going to get very small, very cheap. I can start to put intelligence into everything for next to nothing. Now I can use a computer in the front of my car to predict where raindrops are going to, where they're moving. So where is the raindrop going to be next? If I replace that headlight from the point source with a mirror around it to a very powerful projector, like the one that is projecting on this screen, I could send that information, create a mat, send it to the projector. Now, when I'm driving in rain, I could make my headlights, the light going out of the front of my car, go around and between the raindrops. So it doesn't reflect back off the rain, making me see better when I'm driving my car. Sounds a bit like science fiction, but this is something that has already been done as a project. This has been a research project between Intel and Carnegie Mellon University 5 years ago. And it works. It actually works pretty well. This is what it looks like in snow. You see, this has not been switched on yet. You hear a click. And you can see it actually does get quite a bit better. The visibility improves. So if that is something that we could do 5 years ago, Imagine what we can do now. And this is something that BMW is already working on. You've probably been driving, and you had this experience where the headlights come the other way, the person driving the opposite direction isn't paying attention, and they blind you. And you drive, and you think, we're going to die, and you get through it. We're all alive. BMW is using a laser system to scan the road in front and aim the light intelligently around the oncoming traffic. So you can always have the best illumination on the road possible. So this is something that is here today. Imagine what you could do. The question is, if you can get a smart headlight, why would you ever want a dumb one? Once products become smart, and they will become smart because it's cheap to do so, people won't want to buy dumb products anymore. So smart is going to become an important ingredient of almost every product that's made. If there's value in it becoming smart, it will become smart. So if smart becomes an ingredient, it needs to be easy to design in. If you're looking for an opportunity to innovate, this is a great area. To make it easy for anybody, they don't have to be a C++ programmer or a board designer, to bring smart and integrate it into products. This product you're seeing on the screen here, this is called Edison. It is a full Pentium-class computer with Wi-Fi and Bluetooth on a tiny little board. It's a great place that people start innovating to put smart into objects. It's going to get smaller. This one's called Curie. This will come out later this year. This is designed for fashion designers. It's the size of a button, and it has accelerometers and all kinds of capabilities designed for wearable projects. And it's going to get even smaller. This stuff is going to get smaller and smaller and cheaper and cheaper. This is a $9 computer. What I want you to think about is when that computer is $1 or less. What could you do with that? How would you approach the challenges that you have, the things you're trying to solve? How would you approach them differently? Because the opportunity here is to, like a Trojan horse, think about turning products into services by making them smart. Here's something that Amazon's been trialing. This is a button called Amazon Dash. It's a smart button. It just makes it easier to order washing powder. But it's going to increase their sales, solves that problem, makes it easier for you. When you're running out of washing powder, at that moment when you think about, oh, I need more washing powder, you press the button on your washing machine, because you stick it on there, and it will automatically order washing powder and bring it to your house. So they thought, Moore's Law, we're going to use exponential advances here. It probably costs a lot to make that button today, but it'll be very cheap soon. Smart cows is kind of an odd thing to say, like military intelligence, right? It's how can cows be smart? In Canada, there are farmers who are using intelligence and sensing attached to cows to monitor the health of the cow. Because it's very important in agriculture, if one of your cows gets sick, to take the cow as far away from the other cows as quickly as possible. One, so you can take care of the sick cow, but also so it doesn't spread to the other cows. So they have sensing on the cows, and they have a dashboard, and they can see the health of the cow based on the cow's temperature and how it's moving around. So it's going to solve real problems, being able to put tiny amounts of intelligence into the world and to connect that intelligence. There's great value in connecting products to the internet. First one is you can create new value. So think about that teddy bear. By connecting it, I can connect to an online reading service. What I'm doing there, I'm not making the teddy bear able to read. What I'm allowing that teddy bear to do is to talk to the internet, which is going to read that book, do all of the processing offline. What I'm essentially doing is creating a virtual supercomputer inside a teddy bear by virtue of using a data center somewhere in the internet. It also gives you the ability to constantly upgrade your product. Drivers of Tesla cars are excitedly waiting version 7 of the software, which is going to turn their car from a car into a self-driving car. It also enables you to get service revenue. If you have a product that is copied a lot, you can make sure that it's authenticated. You can make the product stop working if it doesn't constantly check to make sure that it's been paid for. And the other nice thing about connected objects is if one of them learns something, it experiences something in the world, it can tell all the other versions of that product what it learned. So think about robotics. the ability for a robot to experience something, figure out a solution. It can then tell all the other robots how to approach that problem so they can collectively learn. The downside, by the way, of connection is security. Security has to be built in from the ground up to make sure that when you're connected, you don't become a target for a hacker. So when you're designing these products, these smart objects, you have to think about the balance between how much is in the physical world and how much is in the digital world. If you look at the way that things are going, more successful services and products are more and more in the digital world because they can scale for next to no money. So compare what it was like having a record player or a CD where you had a physical musical product versus an app running on a phone or a tablet or a computer running Spotify. And that dumb teddy bear, by virtue of pushing some of it into the digital world, you're able to create all this incremental value. So ask yourself the question when you're creating whatever product or service you are working on, how much can I push into the digital domain? Where am I going to create my value? It also is a different thought process for how you maximize profit, if profit is one of the things that you're looking to follow. Many of you may be working in non-profit environments. If you're seeking profit, the traditional way to get more profit is when you make your product, you try and reduce the cost of it. You figure out a way to make it break after a while, so someone has to buy a new one. Light bulbs are a great example. Or you innovate and innovate and innovate so that you make the last product obsolete, so that people go out and buy a whole new set of products. So that's the old strategy. Once you start to think about using products as a service, there's a whole new different set of approaches. You're not necessarily trying to reduce the cost of the product now. Now you want the product to last as long as possible because the product is the Trojan horse over which you deliver all those services, and you're making your money from recurring service revenue. So you focus on customer retention. You focus on making that device reliable so you don't have to come out and service it. So it doesn't have to be fixed. So by doing that, the focus shifts from product optimization and making it cheaper to making it more reliable. So I think this strategy, this move from product to service, could make the planet more sustainable. Because people are going to focus less on obsolescence and creating obsolescence and more on providing value and longevity. And hopefully, no more warranties. Once you have a product as a service, you don't need a warranty anymore. The reason that people sell you warranties is they want to find another way to get more money out of you. And what they're saying is, if you buy my product, it's going to break. It's going to break. But when it does, I'll fix it if you pay me. Buy some insurance. This is a strategy for creating revenue. Companies, once they've shifted from products to services, they don't need this kind of strategy anymore. As information and technology gets deployed into the world, we're going to have intelligence everywhere. And when you do that, we're going to be optimizing the world. What I mean by that is, once you have Internet of Things, you have intelligence embedded in the world, you're going to be sensing the world. Think about that cow. You're going to sense, what's the cow's temperature? Once you do that, you interpret that information. You decide what to do with it, and then ultimately you take action. You separate the cow. You're always optimizing for something. In this case, the herd's health. The question is, what should we optimize for? When we've deployed computing technology for the last 25 years, IT managers have optimized for efficiency and productivity. And that's good. The opportunity with the Internet of Things, with wearables, with the cloud deployments that we're seeing, is to optimize for something else. Efficiency is an obvious one. But you can optimize for all different types of efficiency. You can also optimize for something else. Maybe you can optimize for the quality of the experience that you're delivering to your customers. You can optimize for safety, for security. I work sometimes consult with a big theme park company. One of the things they're looking at is, how could we deploy Internet of Things to optimize for guest happiness? So when you're thinking about whatever you're doing, if you're thinking about something related to Internet of Things or using technology somehow, always stop. Don't just run to, how do I make it more efficient? How do I make more money? Ask yourself the question, what do I want to optimize for? Maybe we can start manufacturing luck. When you walk out of here at the end of the day, wouldn't it be nice if there was a car just waiting for you? You went, oh, that's lucky. A car. I needed to go to the hotel. That shouldn't be luck. That should be manufactured luck. We should be able to use technology to help think about creating serendipity as a service. The car didn't happen to just be there. It knew, the system knew that you were going to need a cab. Now, cabs in Paris today? Yeah, good luck. Bonne chance. So, we've talked about simple sensing. The other thing that's happening with computing is it's going to make sensing smarter. Virtual reality is finally becoming a reality by virtue of a number of big players starting to enter the market. If you haven't tried virtual reality yet, it is a lot better than it was just a few years ago. And I think it's going to finally take off and have an impact. Virtual reality, in some ways, could become the new search. Huge opportunities here. When people are coming to visit Paris, for example, maybe before they make their trip, they'll check the whole place out in virtual reality. When they want to check out a hotel, let's see what this hotel looks like versus another, using virtual reality. So it could become the new search. Virtual reality could also become the new photography. There are a number of 360-degree cameras that are coming out because all of this content is going to need to get created. What's most interesting to me, though, is not virtual reality, it's augmented reality, which is truly blending the physical and the digital worlds together. Google is doing some secret project work in partnership with a startup they bought called Magic Leap. Looks very promising. They're probably going to be beaten to market by these guys. If you haven't seen HoloLens, it is a fresh approach. How many of you tried Google Glass? Yeah. Didn't really work, did it? And they were just too soon, and they had the wrong business approach, the wrong usage model. It looks like HoloLens has a much better approach. Let me just run a short video to show you what I mean.
Your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
I had to watch that video a few times before I realized the dog at the end of it, which sits down next to him, is a virtual dog. But it could be a really interesting opportunity here to blend the physical and the digital worlds. And it's going to create a whole new set of opportunities to create virtual content, to be able to tell a story, to be able to help to train people, to connect them to whatever it is that might be important to you and your company's services. What it means is that apps are going to become kind of physical. An app takes a different form. It's not something that's flat on the screen anymore. It's going to appear in a very different way in this paradigm. And Google is doing some interesting work on blending the physical and the digital by creating physical to digital relationships using radar technology. So if you haven't seen Project Soli, check it out. There's some interesting videos on YouTube. And what they're using is radar to help you manipulate things in space and make gestures and have them very easily and cheaply captured on devices. So visual understanding. Computers are going to be able to see, hear, and understand the world in the next 5 years or so. What will you do when computers can do that? They've been blind and deaf for 60 years. Finally, they can see, hear, and understand the world. It's going to give us autonomous machines, robots that can safely escape their cages. They've been dutifully building our cars for 30 years, but trapped inside cages, because robots are not safe if they can't see the humans around them. That's why they're in cages today. They will be safe to roam amongst us, and it's starting in trials now. What if you take drones, and I'm not talking about the death machines from the sky, but what if a wearable and a drone came together and had a baby? What would that look like? I want to show you a short video.
In boomerang mode, Nixie will come right back to you. And in follow me mode, Nixie will follow along wherever you go. Then Nixie syncs with your cell phone so you can share your adventures instantly. Nixie will give you a totally new perspective.
4 minutes.
Nixie will follow you on your adventures. Nixie will free your hands. Nixie will capture the moment like never before.
Sounds crazy, but that little board I showed you earlier, that's used to make a prototype of this, and it was shown at CES this year. This was the winner of the Intel Make It Wearable Challenge. The idea that we can start to create entirely new classes of devices that are smart, that can see and understand the world, that can fly off our wrists, turn around, find us, find our faces, take a great picture, and fly back to us. This is what this kind of stuff can do when it all comes together. This is all about bridging this gap between the physical and the digital world. There are many pieces of this puzzle that come together. And I know some of you are working on some of these areas. We've been living in an era where atoms have been translated to bits. Many sectors, many industries, many businesses have been disrupted because of this transition from atoms to bits. And that is going to continue. We've seen it happen with books and movies and music and many sectors that we're all comfortable with and used to now. The question is, what's next? IBM's Watson has an eye on trying to at least augment and then ultimately could replace some of the things that doctors do today. Keys, wallets, they're up for grabs next. One area that's really interesting is sports. What would happen if you could digitize a live sporting event? What would that look like? Well, there's a company that's doing some really interesting work called Replay Technologies. They've created a technology called 3D. What they do is they have a number of high-def 4K cameras all around a stadium. And they're capturing video, high-definition video of the live action, and they feed that. They have maybe 30 of these cameras. Feed all of that information into a big fat computer with lots of Intel chip inside. Dun, 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 dun. And what they do from that is they're creating, in real time, a 3D model of the sports. They're digitizing the sports events. Now, to understand what that allows them to do, it's just easier to show you videos. Imagine the World Cup, the next World Cup, being able to position the camera any way you want. Today, this technology is being used by commentators who've spent the money, for the big networks to be able to say, let's look at that play again, and to rewind it and show you from different angles, and you feel like you're in the Matrix. What happens when that goes to your tablet and to your phone? So that when you're watching a game, you can do the replay in real time yourself. You can put the camera anywhere you want. Think about being able to do that for the World Cup. Why would you have to watch the view that the producer of the TV shows decided, when you could put the camera anywhere on the pitch that you want? You could be on the goal line. Think about how you will interact with that content differently. And then go beyond that. What happens when you can put your headset on and stand on the pitch and look around? What about how you could expand that to entertainment? When you're watching Star Wars 9, I'm so excited for Star Wars 7, but let's say Star Wars 9's coming, wouldn't it be nice to be able to be in the movie, to be in there in virtual reality, to be able to look around? Think about the possibilities. So combining this kind of technology with virtual reality is going to be very interesting for all types of applications, for training, for immersion of all kinds. So I tried to give you a few flavors of things that computing is going to make possible. I could have talked about healthcare. I could have talked about transportation. I picked some more general topics that I thought would be accessible to everybody. But computing in the next 10 years, Moore's law will continue despite the things you hear from Intel's competitors who can't keep up. It's very easy to say Moore's law is dead when you can't afford to keep up. Intel's going to keep it going. So be ready for the type of technology that will come. Be ready for tiny computers that you can put into everything you want. Be ready for massive amounts of computing that can help you solve really big, important problems. Think about what you will do with that. What will you do in that exponential era, in Moore's era? Think about how you can use smart as an ingredient. Before you jump into engineering and try and solve problems with IoT, stop, slow down, and say, what am I trying to optimize for? So think philosophy before engineering. And people who are technical and scientists want to rush into that product space first. Just slow down. Have a beer, talk to a friend, have that conversation. What am I really trying to solve? And finally, stop thinking about products. Go beyond the product and think about the service, the experience, the transformation that you want to deliver, and how you can use smart to do that. I was asked by Nadine and Xavier to come and talk at this event when we met in Chile. I was so excited by the project that they had, because what they're trying to do here, to bring scientists, to bring entrepreneurs, to bring financiers together, is a really important idea, and I wanted to support what they do. So I want to challenge you all. This is a great melting pot of people. Spend time, network. You all came here because you want to change the world. And I invite you all to use at least some of the ideas I offered this morning so that we can all change the world together and say hello tomorrow. Thanks for your time.